This comes out of section 7.2, derivatives of sine and cosine functions. So this is the kind of question we've seen in multiple earlier chapters, especially back in chapter 2. We're finding the equation of a tangent line. We're given a function and we're given, an x value. You would want to definitely find the derivative of this thing, and so I would use quotient rule here, say the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared, so cos squared 2x. I could try simplifying that further, but really I don't need to give a nice expression for the derivative. I just need to use it, put in pi over 6 and see what the derivative equals. So y prime equals cosine of 2 pi over 6 times cosine of pi over 6. Minus minus gives me plus. Here I've got 2 times sine of pi over 6 times sine of 2 pi over 6. All unit circle values. 2 pi over 6 is just pi over 3. And I have cos squared 2 pi over 6. So I can go to my unit circle and say, what do I remember about this thing? I remember the values at the first coordinate here. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1 over 2. And 2 pi over 6, which is up here, is the same coordinates, just reversed. So cosine is half and sine is root 3 over 2. So my value, my derivative here is a half times root 3 over 2 plus 2 times 1 half times root 3 over 2 divided by 1 half squared. And if we crunch all those numbers there, we're going to find that the value of this thing is root 3 over 4 plus 2 root 3 over 4 over 1 over 4. Now, that gives me 3 root 3 over 4 on top, and then multiplied by the reciprocal of the denominator, we end up with 3 root 3, which is the slope of our tangent line. The slope equals 3 root 3. All I need is a slope and a point to be able to do my y equals mx plus b. And I have m and I have x. I need to go all the way back up to the top here to say, well, y equals sine of pi over 6 divided by cosine of 2 pi over 6. And what you should discover, hopefully, is that that equals 1. You've got half divided by half. So here I've got 1 equals 3 root 3 times pi over 6 plus b. Now that doesn't make b into a particularly nice number, but let's just leave it exactly as it looks here. 1 minus 3 pi root 3 over 6, which can be reduced at least a little bit to 1 minus pi, root 3 over 2. So my equation of my tangent line is y equals 3 root 3, that's my slope x, plus this funny b term I just found, 1 minus pi root 3 over 2. Exact value is better than if I started to convert everything to decimals and give an even uglier answer than that.